Welcome. Today we'll learn NLTK or Natural Language Toolkit, a Python library to implement NLP fundamentals like BOW, chunking, embedding, TF-IDF. In my earlier video, we have seen theory part of NLP terminologies. In the world of GenAI, language processing is key, so understanding concept of NLP is also important. We'll cover Python coding to implement NLP. Surprisingly, technology are nowadays very smart to perform actions from any language, be it Alexa, Siri, or ChatGPT, etc. So the very basic task computers are performing prior to do these complex operations are through NLP basic fundamentals. Those are BOW, POS, TF-IDF, chunking, embedding, and so let's learn NLTK and implement NLP concepts through Python.
We have seen the concept and theoretical part of the NLP, embedding, BOW, and then tokenization, all the stuff. Now, let's look into the Python side and the Natural Language Toolkit, which is NLTK. So, we'll write a code and then we'll see how to build the embedding, how to build the tokenization, BOW, TF, IDF, and all those stuff using the Python code. So if you look into NLTK, NLTK is a comprehensive NLP library in Python that provides tool for working with human language data. Okay, so you have like certain string and then you can convert it to vector, you can convert it to BOW, you can see TF-IDF values and everything using this particular toolkit. It supports tasks like tokenization, stemming, lemmatization, part of speech, tagging, and more. It also includes a rich collection of datasets, such as stop words and pre-trained tokenizers. Then we would look into Gensim, like this particular things would require this particular library is an NLP library focused on topic modeling and vector space modeling. Okay, so this is more on the vector space modeling, especially for generating word embeddings. It is widely used for building word-to-vec models. So word-to-vec models that we are going to use over here. This particular code that we are going to write now, it's focusing on the embedding, okay, using the NLTK. So prerequisite for this code is we need NLTK, okay, and we need to install PIP, like that particular package using PIP install NLTK, and we need to install Gensim also, GNSIM, that particular package you need to install. Once you install it, then we can start writing a embedding PY file. So let's create a PY file, embedding PY file, and let's start writing the code. So first we'll import NLTK after doing the PIP install, right? So you can create a folder. I have created a folder, and then after creating a folder, you can create a PY file, and then you can install the PIP one, right? PIP install NLTK. I know, like you know how to install this PIP package, right? And also this package also, okay? These two packages would require for this particular code. Once you import it, then you import also the other one, the modeling one, right? Okay. And then we'll import word-to-vec library over there, vector library, word-to-vector to create the word-to-vector model. And then we would import stop words also, because to clean because if you take any strings, okay, maybe in real world you will get lots of strings. Everything is not required to generate the data or to for your decision maker or to do summarization. You don't need all the data, right? Like stop words or any lemmatization as such, like you have seen, right? Those things you can remove those things. Those are called the pre-processing of the data, right? So these are the would required to to pre-process our data. Let's see. Let's download punctuation. Okay, and then let's download stop word also. So they have the collection of this particular punctuation and the stop words of all the languages. We will implement through English only, but let's put stop words, okay, and PUNT. And then we'll have like one sample text that we are going to use it. So let's have the sample text like this. Okay. So let's have this one. Generative AI is future. Everyone should know GenAI. There are multiple open source technologies to learn like RAG, LangChain, NLTK, and separate other thing. King and queen receives royalty, like some other just random text, okay, to understand it. Now we'll do a pre-processing of this particular text. Okay, let's create a function for the pre-processed text. And the very first one, we are going to use tokenization. Understand? Using Python, right? So that's the thing. We know the concept of tokens, but we don't know how to do it with the programming. If you want to do the tokenization on your own, then you can do it. Okay. So that word required word tokenization or word tokenize, and then text dot lower. Okay. So that text will come from here. We are going to call this function, right? And then when it will come, this particular word tokenize will create the word tokens. Okay. And then to make it a little more like cleaner version, okay, we going to remove the punctuation also. To remove the punctuation, what we can do, we can use the tokens and then word for word, okay. So this will remove the punctuation, okay. So if we go in this one, we can see there are like if it is a noun, if it is a alphanumeric, if it is ASCII. So there are different all the different cases are already defined over here, right? So that is going to remove the punctuation from the word, okay. So that from the tokens, right? So, and then we will put it to another the same variable tokens, just not to use the multiple variables, okay. And then we are going to clean and get the stop words. So to get the stop words, we are going to use stop words and English language stop words. Okay. So stop words is already downloaded, right? So we are going to use the stop words and then we will filter, and then we'll filter it more like we are going to use this. The stop words will come from this one, this English language, and then it will assign to stop words. And then again on the tokens, we are going to use that filter stop words and get the filter words. Okay. So now if you look into the pre-processing area, what we are doing, we are first word tokenizing, okay, and then word tokenize, and then we are going to check and then remove the punctuation, and then we are removing the stop words. Okay, that way we are getting the cleaner data. Let's return filtered words. Let's call it so if we see, this is the clean text, right? Pre-processed text, and we are going to pass sample text, right? This is our sample text, and this will go into this particular flow, and it will come to clean word, okay? And then once the cleaned word will come, then we are going to create a model, word to vec model, okay? So word to vector model. The vector size 100 is the dimensional of word vectors. That is how many features each word in represented by, okay? And then window is equal to 5. The maximum distance between a target word and its neighboring words is considered as 10 context. Then minimum count. Ignore words that appears less than one time in the text. And then workers 4 uses 4 CPU core for parallel training. So these are the parameters that we are going to put in the word to vector so that the model will generate. Okay? So we are generating a model using word to vector. And the next is our embedding. Okay. So let's, the word that we are going to use the RAG word here. So if word in model, right? So if the word in model WB, then we are going to print that particular embedding. Okay. So now, so we have pre-processed the text. We have now get the cleaned word, and then we have created a model with some parameters like vector size, window, minimum count, and workers, right? So the CPU core and the count and the window size and the vector size. So that way we have created the model, and then in the model, through the model, we are going to get the embedding of RAG. Let's have that one. Let's run it. See, so this is the embedding of RAG. Cool, right? So you have seen the code, like the theory side. Now we have seen the Python side, how to create an embedding of a word or get the embedding of the word for your text. Okay, so if you want to create that one, you can create it on your own with a defined text and defined stop words or something. You can play around it. Now, if you want to get the similar words, right? So let's get the similar words. Okay, so we can find out the similar word related to RAG. Let's see what are the similar words of RAG, because that is very important to get our generative AI to run. There is a concept of generative, right? It finds the similar words from the RAG perspective or from any other prediction perspective. See, most similar word RAG is everyone, technologies, AI, and receive. So it is actually performing some calculation, and based on the calculation, it is finding out and returning the similar word. So this is the NLTK. This is the first program of NLTK, Natural Language Toolkit. You can play around with it and understand more. We'll create another one of BOW. Okay, let's move to the next module.
Do you want to achieve success in the world of generative AI? Then it's a time to level up. To truly stand out in the field, you need to master the essentials: prompt engineering, LangChain, RAG, advanced RAG techniques, agentic AI, and cutting-edge platforms like AWS Bedrock, Google Vertex AI, and more. Whether you are a beginner or professional looking to grow, these are the tools and skills shaping the future of AI. So why wait? Start learning, start building, and start leading. Enroll in our hands-on Udemy courses today, link in the description below. Or reach out to me directly via LinkedIn for personalized guidance. Let's build your Gen AI journey together.
Now we are going to see bag of words and TF-IDF using NLTK. So bag of words, we are going to use count vectorizer, okay, library, and for TF-IDF, we are going to use TF-IDF vectorizer. Both techniques convert text into numerical representation, that is vector, making them suitable for machine learning model. Bag of words captures word occurrence that we know, right? And TF-IDF reflects the importance of a word relative to its frequency, right, in the total context and corpus. So what is the prerequisite of for this particular code? You need to have SCI KIT learn, okay? So that particular package you need to install. From there, we are going to import the libraries, count vectorizer and TF-IDF vectorizer, okay? And then we'll use the text data, use our, like, let's use the cat sat on the mat, the cat lay on the rug. So this is the text data. We have two simple sentences that will be vectorized. And the vectorization process, the count vectorizer is initiated with the parameter stop words, English, right? To automatically remove common English stop words like the, on, we are going to remove using the stop words. Then we'll do fit transform. This is called on the sentences. This is called on the sentences to fit the vectorizer to text and transform the text into matrix of word counts. So we want to count the words, right? So that's why this fit transform particularly does. Once we do the stop word and then filter it, and then we are going to get the count. Then this result is a sparse matrix, which is converted into dense array using 2 array. Okay, then we can easily manipulate it once we get the array. Then we have this one, right? Get features come out. Now let's print our feature names. We can print the features name, print all unique words identified by the vectorizer, and then print entire TF-IDF matrix that we are going to print it. We can see the print output of this one: cat, lay, mat, rug, sat, and bag of words matrix is like this, right? First sentence 10101 and then 11010. That we have seen, right, in the theory part. So bag of words, if you want to print the first line and the occurrence, you can use this particular print statement and get the output, right? Bag of words of first line, cat 1, lay 0. Let's focus on the TF-IDF. So for the TF-IDF, we are going to use TF-IDF vectorizer, right? So this is the one same thing, like stop words. We are going to first clean the stop words. We don't need the stop words, right, in the count. And then we need to fit to transfer of that particular sentence, okay? And then once the fit to transfer is there, then we need to extract the feature names from the vectorizer. Once we get the feature name out, we can now, once this feature name will come out, then we need to convert it to our array, okay? So let's convert it to the array, TF-IDF matrix to array. Once this will come to move to array, now we'll see all the feature names, okay? Let's see the feature name. So feature name will have from the vectorizer feature name, and this is the matrix, right? So there are two things. One is the features and the second one is the matrix. So let's get the feature name. So these are the feature name that will similar to our back of words, right? But here cat, lay, mat, rug, sat, cat, lay, mat, rug, sat, both are same, right? The features, but the matrix will vary because TF-IDF goes with the frequency, okay? So now if we look into the frequency, we'll see some decimal values for sure, not like just 1 0 count. So here you can see the TF-IDF matrix came out, right? So that's the good thing. Now if we want to print with a specific line, what is the line of that particular, or TF-IDF one of a line, if you want to print TF-IDF of a line, then you can use this particular print statement. So now you see this is the one. So at a nutshell, what we have done, we have two libraries, count vectorizer and TF-IDF vectorizer. Count vectorizer for our this one, our BOW, and then we convert it to, we remove the stop words, we put it to fit transform, and then convert it to array, and then extracted the feature name, and then get the matrix and print the feature names and matrix. Similar way for the TF-IDF also, we have done the similar thing, right? Similar process. So this is the power of NLTK. So you play around it, understand it, and thank you.